Hello, test test. We have a stream. Welcome to Amber Skies. My name's Blades, and yes, what are we doing today? I don't know. Yes, I do. Whiteboard. Time. Got an eraser there, Anna. Okay. It's time to talk about time. How important is time? Well, yeah. Oh, I called it Delta time, did I? Okay. That's good news. I've checked over the repository. It is now public. Yay! Here it is, our public repository. Issues, pull requests, discussions. Yeah, look. See, we've got discussions. Pull requests, if you've got any ideas, put them in here. Issues, if you find a problem with what I've written, put it in here. Code, obviously. Go to not the master, but the research. You'll find my research is in here, which is what you're looking at here now on screen, is all the research stuff. Haven't decided what to do about Add Project yet. Okay. And I haven't decided what to do about the wiki. Okay. We might look at that later, because we'll probably have free time today. Haha, because we're doing time. How important is time in a game? It's immeasurably important to have time, or be able to know what the change of time is between frames, as that will govern the movement of the objects within your game. Objects should not move faster than time permits, and your frame time. And that's what we're going to measure, is the frame time. Because we need to multiply any movement that we do to our objects within the game by the change in time per frame. If we don't, then somebody with 144 hertz or 140 hertz monitor will literally run the game faster, and things will move faster than somebody on a 60 hertz frame. Monitor. Coffee. Nice coffee. So we do need that, because otherwise, if you have a faster monitor, you will have an advantage within the game, or the game will run at the wrong speed. And that would, well, upset the players a little. No, a lot. No, massively. And it might even, in the future, it might even make your game unplayable as monitors get faster and faster and faster. The refresh rates get faster. What's the refresh rate of reality? If you can answer that question, put it in the comments below on YouTube. Yep, this is going to YouTube. So, Fraser Sharp over on YouTube. Yeah, I've got it on screen now. Go find it. Put it in the comments. This video goes up tomorrow. And we are on the 29th of January 2022. So this file is already 6 days old. So we're nearly a week in. haven't even drawn a triangle on the screen, because I'm not going to. That's not the point of this. Well, maybe not until tomorrow. The point of this mini engine is not necessarily OpenGL. It could be if you want it to be. That's your choice. For me, I don't care. Why am I writing it? Because I want to write a game. Well, I have written a game, and I want it in a structured format. And I want to develop it in a structured way, because every time I try and write it, it just becomes a mess. So, yeah, there's that. How do we want to approach delta time? Let's just have a look at the bits and pieces inside of delta time. Now, these are my thoughts from literally 30 minutes ago. I just sat down and typed out my thoughts. How complex is time? What exactly do we need? And how exactly do we want to get, how do we want to program it? Well, firstly, we do need it within our application. So our application will need a time. Here's our application. So our application will require time. That we do know. So let's put time in. Actually, I'm going to call it delta time. So we have a dependency, don't we? And that's going to depend on nothing. So we have create window, and we've got a Windows interface. So we're going to use this interface to get our time. So that's good, because that is then platform independent. So we can have it. The implementation of get time can be in here. It's in GLFW. That's perfect. We can get that from our Windows window. Yeah. So that helps, because that means I can make that independent. Good. I don't want to put GLFW in here, obviously. So we do have something we can use. Create window. Good. That's the first thing. We need to be able to get time. So delta time is literally just going to be this little thing that we are going to attach to the application. And this will then allow us to control the time rate of anything in our program. We can add that to our layers. On update. I think that's what I'm thinking. Yeah, that's what I was thinking about. So we need a class. Or do we? Do we need a struct? There's no goddamn difference, so we'll have a class. Alright. How complicated does it need to be? Not complicated at all. Let's just have a header file then. We'll call it delta time, or should we? Can we not just call it time? Dunno. Let's add that and find out. Well, nothing blew up, so we're alright. What did we do the last few couple of days, or the last thing that we did? Input. Will do. No, I'm not allowed to make a mess of this today. So let's put our namespace in. That's obvious. We'll need a class, I guess. And we're going to call it time. And we're going to have to probably keep hold of that time. Privately. What we do in public is up to us. Okay, so we'll have public. We need a constructor. And that's going to be float time equals 0.0f. So we've got a default. And that will be m time. We'll pop in time. Okay. I think I'm alright with that. Yep. We can inline this. There's no real point in us writing anything in here of any importance. So we'll have an inline. float, get time. Oh, wait a minute, yes, there's that problem part as well, isn't there, with time? We're going to have a class, and we will want to be able to convert that into a float. So I did make a little note in here. That one. What does this do? It allows us to cast to a float our class. So to allow a class to cast to a float, we have to put that in. Of course, I had it in my notes, so I didn't add a semicolon in. I don't put semicolons in notes, if I can help it. So that's a little special thing for you, something to learn for the day. If you want to cast a class into a different type, you have to tell your class that you can do it. So get... Well, the class is called time, so we'll call it get seconds. It will be a const because we don't want to be able to change it. And that's just going to return underscore time, because that's what we're going to measure time in, seconds. There we go. People might want more from this system. What more could they want? How's abouts? Inline. Float. Const. How's about get milliseconds as well? You might want it. You might. People usually don't mind milliseconds. Why is this a problem? Oh, right, okay. Const. So that will return time. How many milliseconds in a second? 1,000. Oops. There we go. Anything else? Any other calculation we want to do for our user? Not that I can think of. There we go. You might notice we don't actually query the computer for time in our time class. And there's a damn good reason for that. We don't want to tie our time class to this. It's independent. It just floats around. You can then change this class without breaking anything. If you change anything in this class, application will recompile. Entry point will recompile. And of course the sandbox client is probably okay. So let's see what recompiles currently. Interesting that it will do application because I changed it. Notes. You see? So you can tell your dependencies. So it's just time.h that we've changed. But of course time.h is a header file. It doesn't compile. See? Application.cpp because I changed something in there. Time.h doesn't even compile. So we can change this freely without recompiling. So we can add to these anytime we want. I think inline should be okay. Yeah, it will be. I was trying to decide where to access time from. This line here. Okay, let's have a look at this application now. So we have to include time. So let's do that. Oh, I've got window.h there. Have to have a look at that. Any second now. Hash include. And it's just going to be time, isn't it? Not a big class, is it? In fact, the size of the class is one float, which is interesting. It's how much memory it takes up. Because that's all we're storing. Okay, let's have a variable. What should we call it? It's going to be a delta time, I suppose. Or is it just going to be a float? Alright, so we've got this rubbish here. That can go. We've done that. Now we're into this stuff. Let's make one of them. I'm going to make it into a float. It's a private member. I don't like initializing private members in here. There's a big reason for it. I'm not going to go into it, but I don't like doing that. So in our application, we can either do it at the top or down here. We're doing the instance, the log, see, we've done it here. Alright, can we stop doing this, please? We initialize window, instance, layer stack. Do we do layer stack? We don't seem to. That's bad. So it's a singleton. That gives it away. Where do we initialize layer stack? Do we need to? Yeah. I can see where we're using the layers. Okay. See, there's not much to our application, and yet we don't seem to be initializing it. And the computer hasn't complained about it yet. That's even more interesting. I'm going to have to check that. I'll have to write a test, probably. We're quite happily using it. That's very interesting. Okay, so what should we be doing? Instance is done, window is done. So we need m running equals true. Let's do it properly. There's a reason here, so that you can see them. We'll put you to true. M underscore last frame time. Put you to 0.0f. And that's the reason, so that we can damn well see it. What are these dotted lines for? Consider adding it to a hint file. Pardon? Why? What's wrong with this variable now? We didn't say that. As soon as I save something, the graphics card goes whizzz, as Visual Studio tries to work out what I've just done. Interesting. Okay. So we now have a zeroed frame time because we start at 0. We don't have a frame. That's pretty obvious. So in our runtime here, we first of all need to be able to issue a command saying float current time equals that. And I said we'd do it in window, didn't I? So what have we got in window? Or what would we like the API to say? So we're going to have, because we're going to have to split GLFW off, so our window is going to give us this. And it's going to be get current time. Are we going to be altering it? No. Oh. Expands to get tick count. Ah, we can just say get time. Isn't that nice? There's a hash defined somewhere saying get current time. Nice. So now what we need to do is go over to our GLFW area, which is here. And we take that with us. So it goes in here. It's no longer virtual. do with something being returned. It's not a void. I just don't know what it is yet. Sorry. So I can't return anything until I know what it is, because I'm writing this the wrong way round. Well, it doesn't matter, it's still virtual. Actually, and we could put it as inline. Yeah, we could. The virtual word doesn't mean anything at this point. And what we're going to do, we'll do it in line so we can do it in here. Return glfw. Oh, sorry, glfw get time, maybe. Oh, there you go. It's a double. Okay. Returns the GLFW time. The function returns the current GLFW time in seconds, good, unless the time has been set using something else. Returns the current time in seconds or 0 if an error. Interesting. I haven't done this file properly. Oh well, clean this up then. And of course, get time doesn't exist, so hey ho. Return type is not identical. Yes, I know it isn't. Save all. Okay, that's that done. And that's how easy it is to keep your GLFW out of your application. It is that simple, yeah. But it's now attached to the window, which doesn't matter to us. I hope. Because we have one. So that should do. We'll pop it on the window because I don't want to do a separate one. Is that the best place to put it? No. It should really be a utility. API. So yeah, I think we're going to do it that way. So now our window has a function that can get the time. Maybe we can write it now. Make sure we can compile. Yes, we can. Good. So what we want to do is say float, but it's a double. Time equals float underscore window get time. And that works. Fantastic. I like programming when it's structured properly and you have some kind of architecture in your favour. Otherwise, if you don't have the architecture in your favour, it becomes very, very difficult. As you can see, nothing broke. Just by we altered the API. Right, so we can do that. So now we can say time, delta time equals our time minus the last frame time, which is why I had to set it to 0. Okay, we're happy with that? Looks okay. And then of course we have the last part, which is m_last frame equals time. And that's it. That's all we need to do to this point. But now we have to change our layers to use them, as each layer will be able to interpret delta time as it wishes. So on update, in layer we'll have to have time included. Damn. Can we allow that? Layers is part of application. Okay. We've done the window and sorry, the window API and that. That should really be called a window API, shouldn't it? Really? So if I change that name there to window API, what breaks? Well, application does, because it's using it. Oh, sorry, no, I don't need to do that. I'm still calling it window. So all we have to do is change that, the include. Does that break our system? Let's have a look. Windows window glfw. No, it doesn't break our system. This is outside of our system. Okay. We haven't changed any variable names. Okay. There you go. Wow. That was hard to do, wasn't it? Yes, we just changed an include name and, well, hardly anything happened on breakage. That was nice. That's how you can tell whether your architecture is correct or not. You shouldn't be breaking things. And include is a massive change. But as you saw, it isn't. Okay, what do we want to have a look at? We want to have a look at layer. Okay. Remove you, because that's in common. And now we just need time. And we can go down here and say time delta time. And you might notice it's a virtual void. That's an on-detach. I don't want it in on-detach. On update. Yeah, we're happy. I'm not even sure I need that. Because I don't really want that. Because that then ties time here and time in our application. So if I take that out, we should get red squigglies. And we don't. That makes me suspicious about that. Unless it's got to red squigglies yet. Ah, good. There we go. The compiler knows, even if our poor, lazy, IntelliSense doesn't know. So we can't just do that. Okay. So let's just put time up here. Will that compile? No. Might do. Ooh. Yeah, that's not the way to do it. I'm still not happy about this kind of thing. I always used to think it was using. Something like that. But it isn't, is it? Maybe that was a different language. Well, there's one way to find out. Because layer indirectly is going to be used in the layer stack, which goes into the main application. What I don't want to do, it'll still have a dependency though, won't it? Because this is C++. So will it really matter if I do it this way? If you take the layer out of the application, then it'll break this. So if you want to separate the layer in the application, you will not be able to do so. So that's a bad idea. Okay. And yes, I think about dependencies all the time. We will make it dependent then. What do I want? Time. Okay, it'll all work now. Ah, it knows. Fantastic. So now it's just prompted us to say, hey, hold on a minute, you've got an update here. It didn't ask for it in that one. Okay, because it's not a, yeah, okay. So hold on a minute, we need it in here. So we'll put in time. And it's delta time, isn't it? There we go. Delta time is already a time. So we now have a time class, which is a float, by the way. The size of a float being thrown around our system. A float is okay. We're not going to take that by reference. I think it's what, four bytes? Something, I don't know. Can't remember. Don't want to remember. Looks okay to me. Yeah. That's okay, but we've just broken something else now. Well, that's it. That's all you need to do. We now have delta time in the onUpdate function, which is where we would do it, not in the onEvent system. We would not propagate events with a delta time wrapped up inside it. That would be daft of us, because the operating system is different, may act differently on each machine. So to make sure that delta time is constantly accessible in the same way, and one frame at a time, because that won't go by frames. onEvent isn't frame dependent. onEvent is operating system dependent. So this is frame dependent. It's in our running. So we have one frame. So this runs once per frame. This runs once per operating system event type of thing. Well, dependent on operating system. So that now breaks something. So we've now got delta time. That's a lot simpler than a lot of people do. It's just 3 lines of code and a small little class the size of a float. Very minimal. But obviously now we've got a problem. If we go over to our sandbox, shouldn't be a problem. Okay? Yeah, we're pushing layers, not a problem. Let's go to our research. Oh, not a problem. But there is. It's in on update. It's in the header file. Time. Delta time. Actually, call it something else. Time. I'll call it D time. Oh, but we haven't got time. That's all right there. Why am I doing it there? Why have I got squiggly lines here? You see, I didn't even spot that one. Because it's not part, this file isn't part of the engine. This is the user's interface. So what do we want? Time. Add it to the end. There we go. So we're back at research. T, I, it's amber, time, time. Okay. It's now telling us that we need to change our onUpdate method. Here. And now, because we placed that line in time, this here, we can say the following. Float And that's how you use it. You can now multiply your movement by delta time. You can't multiply by a class. Let's be honest. And that's it. That's that one done. There we go. That's research done. I'll do some more in there in a second. We now need to fix rendering. Okay, so we've fixed rendering. How can we tell that it's working? How's about doing a dev trace on it? So, error, fatal info. Do we not have trace? Yes, we do. What's this going to go like? This is going to go like research, isn't it? Because that's how I do it. So the change in time equals seconds and put a colon. The next argument we will put as milliseconds. And that's going to be time dot get seconds time dot get milliseconds. So, does it work? And this should be pumped out once every 60th of a second. Let's just build. Rendering and research change. Sandbox app. Why did it do that? Don't know. Who cares? And here we go. I'll just freeze the output for you. As you can see, in seconds it's correct, in milliseconds it's not. So what happened? What went wrong? Not sure. The seconds is correct, but you can see it is 16-ish. Something's not right. And there you go, it's here. Okay, so we changed one thing. What happens when we run? One thing compiles. Okay, let's just take a look at the results. There you go. So 16.5, 16.7 milliseconds. It averages out to about 16.67676767. But anyway, that's beside the point. You'll see that sometimes the frames are slow, other times they're a bit faster. But on average, you're going to get hit 60 frames per second. Well, 59.999. But that's irrelevant. And your seconds are correct and your milliseconds are correct. So you can multiply by either. So when I said that time, I was wrong. Delta time equals time dot get seconds. And there's your answer. And that's how you add time to your game. And you can now multiply by delta time anywhere you wish. Like in here, if the W key is pressed and the thing moves forward. So increase player's forward position. Please don't forget to multiply by delta time to give movement per frame and not just by key press. So now we have delta time. Here it is. Wow, that took a bit, didn't it? Was that difficult? Not really. Does it accept the rules that we set here? Is delta time dependent on anything? Okay, so if I make a change in delta time, what needs to recompile? Let's find out. This is, you need to look at this because it matters so much later on. You don't want to break your system. So you go to time.h and you make an alteration. There you go, there's my alteration. I hit the space bar. So if I now build, application builds and layer builds, layer stack, Windows input. That's a lot of dependencies. So all of these 4 things are dependent on this class. If you make a change in here, you could break any one of those. That's not good. So why does that come up? That's the one I want to look at. That's the wrong one. Windows input GLFW. Because it includes application. And we have made a possible change to application. Why are we including application in here? What breaks if we don't have application in here? Let's find out. That. Oh, it's getting the native window. So it's using application to get the native window. That's interesting. Could we not put that as part of the API? Does our application really belong out here? Can we move it? Can we change it? Or are we stuck with it? Is that the only one? Yeah, it's the only one. So we've only got that one line. What the hell has that got to do with time? It's got nothing to do with time at all. We've got an input API. There's nothing to do with that. Is pressed implement. That's these implementations. And then we've got this thing at the bottom in private, get instance window. That's to allow our implementations to work. So we do need the window. Is there any better way of doing that? And there's your puzzle. There's your homework. Is there a better way of doing that? Currently? Don't know. No, it's having to redo the lot because I've put something back in. Okay, that's fine. It goes to show the dependencies and how you've got to be very, very careful of what you do. It was on input. As well. And that one's alright. So that's it. That's how you do time. Simple, straightforward, and it will keep your program in time with each frame. Or the frame rate. The faster the frame rate, the lower the time. The smaller the time. So you multiply them through, and of course, it just makes things move less. Pretty simple stuff. Right. I think I've done that one. And I'm happy with that result. But I think I've got to be careful with how we're constructing this. Otherwise, we are going to get dependencies which break for no reason right across the whole of the game engine. I'm not overly bothered about things in the platform, because that's not part of the game engine. What I am bothered about is things in here. Okay. Told you I'd do delta time today. Didn't realise I'd do it so quickly, but hey ho. I have been careful about what I've been doing, and I have tried not to make a mess. We now have delta time.